Hi, my name is Oskar Kosz, and I'm more than happy to present this paper called A Model for Custom Bibliographic Databases Creation, Machine Learning Approach for Analog Documents Inclusion. The video is organized as follows. First, I will start with some introduction, then I will go to the methodology section of our article, then I will report results, bring the conclusions, and conclude further with limitations and propositions for further research. The issue of data sources for bibliometrics and systematic literature reviews are far beyond the usual concerns expressed in studies utilizing these methods. While usually the limitations of the study that stems from the database imperfections are mentioned, they rarely depict the complexity and choices that are made with the database selection and preparation, raising a question if researchers do not believe in the database's integrity inadequately to the reality. So we have made a literature review to investigate this issue, and I believe that one of the pieces that make strong point was the one by Judith Bar-Ilan, A Tale of Three Databases, when we can see that each of the databases will show us different results and therefore bring us different conclusions. So, however, custom-made databases might include bias. These bias nevertheless have already been part of existing databases. The problems with different conclusions and results might stem from different reasons. So these different reasons also form the basis why we should actually introduce model for custom bibliographic database creation. To list some of them. For example, Web of Science was discussed to be inclined towards English language journals, and this is a conclusion that repeats after time and in different papers, and only handful of papers are in language other than English, and we can find that even compared to Ulrich's score, there is huge overrepresentation of English papers. And these are not only English in terms of language, of course, but English in terms of country of origination, being dominated by United States and United Kingdom publications. Also, there is strong evidence that this supports the core-periphery model of scientific production. Regarding other types of publications than articles, it was suggested that through the references, plenty of books might be found, but actually, after some further investigation, for the case of Malaysian university presses, the conclusions was that only 45% of books were ever cited, so other 55% are not to be found in databases through citations. Franzen and Nicolaisen showed that the case of economics and psychology is very specific, as there exist intradisciplinary differences between databases. So we can come at different conclusions even within single discipline. All the issues mentioned led us to development of model of custom bibliographic database creation procedure. One that would allow us to overcome the issues mentioned and create a database that reflects more closely what we try to study. So of course we start with database search, that is very common to do, as these databases that do exist, they provide us plenty results on the research topics we try to investigate. And through the different databases queries and merging them, we end up with a collection of seed documents. seed documents we use for the forward and backward snowball search iterations. So we start with backward snowballing, then we go with forward snowballing, although the choice to start with backward or forward is actually up to the researcher. Nevertheless, through this snowballing, we obtain some additional documents that we need to include in our collection, nevertheless, if these documents are in digital or in analog form. So we start with digital documents, and then we scan these that only exist in their physical form, and therefore we end including identified documents into our data set. And then we repeat the process until we actually cover everything and we cannot find further publications no more. So when we came up with this model, we had a problem that we didn't know if it's actually working. I mean, the metadata extraction from digital documents is well covered, but the metadata extraction from analog documents, it's not so easy, and it's well, not a task that is well described in current literature. So we tried to investigate if we can actually introduce this model into research, and we made this research of exploratory type to answer the question if database could be created for the case given using the model proposed. Of course, this model it didn't came up from nowhere. It was made with morphological modeling as a basic scientific process to develop this model. And we used this case study to evaluate the use of this model. And we have not included a part for forward snowballing, as the procedure similar to the one presented in extant literature could be employed. That's the first reason. The second is that our case is of methodology scholarship, and it's not so frequently cited in forward snowballing, so that was not necessary for us to cover forward snowballing. And trying to check if this model actually is to be applied in real life, it required machine learning. So this is why we have this another part of our title, the machine learning approach. We used a bunch of neural networks for different reasons in our research. We use TensorFlow to develop them and to actually train them and then use in Python. We have segmented over 200 photos of books for the model of pages extraction from scanned books. We have applied a lot of transformation and cleaning using OpenCV in Python, of course. And then we have utilized Tesseract OCR to perform optical character recognition on these scanned pages to obtain text that could be further processed. And any style was then used for metadata cited references parsing. And we have used a dataset of almost 2000 segmented references to train the parser and to evaluate if such a parser is of use for further research. So here are the results of the database search query. We can see that Scopus returned a lot of articles for worldwide case and plenty of them for Europe, but actually for Poland and we investigated the Polish methodology of management sciences. It returned only 68 documents, giving us a very high number needed to read to actually filter out irrelevant works and come up with articles that are relevant. Unlike Scopus, Web of Science have a lower number of initial hits, but it has almost twice as much of Polish affiliated articles. So we can only tell that although Scopus is believed to cover Europe more, European science more in more comprehensive way, that was not the case for what we have studied. Here the Web of Science performed better, and we have used our country level database called Bazekon. It's a specific database used for management sciences and economics and for Polish science repositories. So we had 905 hits, and 81 of these were actually connected to the topic we had researched, so the number needed to read was surprisingly high, as in the case with Scopus. Here is the figure that is not in our paper, but for the sake of some extra knowledge being transferred through conference, we believe this is a good choice. So here is a photo of book in the resolution used by our networks, and then is segmented, the figure of segmented book pages that we have used for further Model 3 training. And here is the video showing how this training actually was done. Of course, these parameters of trained network are not the same we have used in production model. We have used a lower number of epochs, and we had another parameters, but this is a kind of exemplary video showing how model could be trained and was trained for our case, giving us pretty well approximation of book pages for their further extraction and perspective transformation. So after pages identification, we have actually applied trapezoid detection and transformed identified trapezoids into pages, then cleaned them up and performed OCR as is seen on the right side. The critical issue of our research was the accuracy and reliability of metadata extraction, that is, cited references segmentation for the respective fields. And as we might see, the accuracy and F1 scores are actually pretty high. For a compound author date title synthetic key that could be used for distinct publications identification and further statistics was actually above 90%, and we believe it's pretty good for the stage of research we have now. And during the research we have found out that the training sample size, also called volume, highly influences our error rate, but only until, let's say, 500 references segmented. Then the decrease in error rate is not so big. What proved to be crucial to decrease the error rate was actually training sample variety. So the number of different sources from which the segmented references come. The higher number of different sources, the lower the error rate was. And this also contributes to our further conclusions on how to create such a dataset for any style parsing. So the first conclusion and most important for us was that the proposed model can be successfully applied and should be further developed, and we are actually undertaking such development. The second is that pages extraction and cited references parsing presented fair performance, and that for cited references parsing, 1,500 references from at least 100 unique sources should be used to give results good enough for a complex study, while for single field extraction, for example authors or title, even 250 might work. Better than segmenting few articles for references, it is to sample a couple of references out of each document we can to achieve higher variety and overall accuracy. Every study comes with limitations, and of course ours was not free from this issue. So certain topics require strict inclusion criteria for reason of relative popularity of keywords, and this was demonstrated in our case with high number needed to read, especially in our Polish database, when it appeared that some of scholars use the keywords, but these keywords do not describe their research, not in the required level to include these documents. The second limitation stemmed from the fact that enlarging cited references data volume and variety should increase the accuracy of the model we have used as well. So although we propose at least 1,500 references to be used for model training, we believe that further increasing the variety and data volume should end with obtaining better model, and that is actually what we strive to do. And using better models allows us for more precise research output, and this is a limitation since we try to develop better models, but also this is also kind of further research recommendation. And we have far more propositions. First is that the full text analysis could be carried since we are scanning our documents, these that are in their analog form. The second, that models for books, sections, extraction and citations attribution should be constructed to allow us to segment books, which are very large in terms of pages, into smaller chunks. And the last one is that software that takes images as input and provides bibliographic records as output should be developed. Thank you for watching our presentation. And since we are developing this software for automatic extraction of metadata and creating databases from photographed books, if you have any questions or suggestions, we propose to stay in touch. Here are our emails.